Okay, so this morning we're going to play with KNN. So I'm going to start by looking at the MT cars data set, just MPG and displacement, and sort it by displacement. So we'll call it demo. Start with MT cars, select MPG and displacement, arrange by displacement, and print out demo. And here's what we get. Okay, and I'm just looking for a value that doesn't occur naturally. Let's take 110. It's between 108 and 120. Okay, so let's see. What I want to do is estimate miles per gallon for a vehicle with a displacement of 110 based on the 5 nearest neighbors. So I'll call this thing result. Start with demo, and then calculate the distance of every value of displacement from 110. Then arrange by distance, and then take the top 5. And because the sorting is in ascending order, the top 5 will be the nearest 5. Okay, so what we will do to get an estimated value of MPG based on 5 nearest neighbors is take these 5 values of MPG and we come up with 24.42. Okay, now I want to convert the code above to a function which will return an estimated MPG value for a given value of DISP. And I want to make the value of k a parameter of the function, tested with k equal 3 and k equal 5. Okay, let's see how we do that. So I'll call it MPGest. It's a function of a particular value of displacement, DISP 0, and k. So you recognize the code here. And instead of head of 5, I've got head of k. So I take the MPG estimate of 110 with a k value of 5, and I get 24.42. And I take the MPG estimate of 110 with a value of 3, and I get 23.4333. Now, I want to look at our function to look at a set of values over the range of DISP in the data set. So let's get the min and max values of DISP for this data set. The min is 71.1, the max is 472. So I want to use the sequence function to generate a range of values. And I want to go from 70 to 470 with a step size of 10. Okay. So DISP values is sequence from equal 70 to equal 470 by equal 10. Okay. Now I have to create a vectorized version of MPG estimate. I'll call it VMPG estimate. That's a vectorized version of MPGest. That's so that we can apply the function to a whole vector of values and create a vector of results. It's simple. VMPGest is vectorized of MPGest. Now I want to create data frames of estimated values based on k values of 3 and 10. Okay. Let's look at how we do that. MPG3 is VMPGest of DIS values, comma 3. MPG10 is VMPGest of DIS values, comma 10. Then I create data frame 3 is data.frame DIS values, comma MPG3, and DF10 is the same thing with MPG10. Okay. I want to create a plot showing the two KNN estimates, the actual data, and a linear model. Think about a minute about how to do that. Let's take a peek. So I start with demo, and I'm going to do a ggplot. This gets me the actual values. X is DISP, Y is MPG, GM underscore point. Then to get the linear model, I stick in a GM underscore smooth with method equal LM, and the color is blue. Then to get the values with K equal 3, I have to change the data equal DF3, and the aesthetic is X is DISP values, Y is MPG3, and make those points red. And to get the values with K equal 10, I need another GM underscore point, but this time I have to use a different data frame, DF10, and the what you'd expect, Y is MPG10, color is green, and then I added title, GG title, 3 and 10 nearest neighbors. So what do we see? Well, if you look at the three estimates, notice that they track the points pretty closely. But the green estimates, they're much more moderate in going off wild. They track the points better than the line, but they don't they don't hug the exact points as closely as the 3 estimates do. Okay, so that's the way KNN works.